everyone, and welcome back for another deep dive. Today, we're going to be heading out to Saturn's moon Titan. Yeah, we're going to be talking about NASA's Dragonfly mission, which is set to launch in 2028.
Yeah,
and
this is a really cool mission.
You know what's really neat about this is that it's not just like a rover.
Right.
It's a rotorcraft lander.
A drone.
Yeah, basically a drone. It's going to fly around Titan.
On another world.
Yeah, drone on another world. And we've got a bunch of articles and research on this, including some recent news from NASA about SpaceX being chosen for the launch.
Yeah.
So before we get into like all the details of the mission, let's talk about why Titan. Why are we sending a drone all the way out there? What makes it so special?
Titan is really unique in our solar system.
Yeah.
It's the only moon that we know of that has a dense atmosphere.
Right.
And this atmosphere is just brimming with organic molecules.
Okay.
Not just any molecules.
When you say organic molecules, what does that mean?
So we're talking about things like tholins.
Tholins.
Yeah.
You haven't heard that word before.
Tholins are these complex organic compounds that form when sunlight interacts with the nitrogen and methane in Titan's atmosphere.
So what's so special about them? Why are scientists interested in them?
Tholins are really fascinating because they're thought to be the building blocks
Oh.
for even more complex organic molecules, the kind that might have been involved in the very origins of life.
Wow.
So think of Titan, like a giant prebiotic chemistry lab, a snapshot of what Earth might have looked like billions of years ago.
So it's like a time machine almost.
Yeah, exactly.
Oh, okay.
A time machine to early Earth.
That's a pretty compelling reason to explore Titan. Okay, so you mentioned a dense atmosphere. How does that play into Dragonfly being a drone?
That's one of the reasons why a drone is actually a perfect fit for Titan.
Okay.
The dense atmosphere, while it makes it tough to see the surface, it actually makes it easier for a rotorcraft to generate lift.
So the atmosphere is both a benefit and a drawback.
Yeah, it's kind of counterintuitive,
Yeah.
but the weaker gravity on Titan, combined with that thick atmosphere,
Yeah.
creates an environment where flying is surprisingly efficient.
Interesting. So are there any challenges that Dragonfly might face because of the atmosphere?
That's a great question.
Mm-hmm.
The density of the atmosphere, while helpful for flight, also means that visibility will be limited.
Right.
So Dragonfly is going to have to rely on some really sophisticated radar and sensors
Yeah.
to navigate and avoid obstacles. Think of it like trying to fly through a really dense fog.
So it's not going to be easy.
No.
Okay, but this isn't just a sightseeing tour, right? This is there's a very specific mission here.
Exactly.
Dragonfly's main goal is to search for signs of life.
Yeah. Or at least the building blocks of life.
Right.
We're talking about searching for biosignatures.
Yeah.
Those telltale chemical signs that life has been present.
Okay.
Now, we're not necessarily talking about finding, little green men out there,
Right, of course not.
but rather evidence of past or present microbial life.
Okay.
And we have to remember that life on Titan might not look anything like life on Earth.
Yeah, you mentioned earlier that it could be both water-based and hydrocarbon-based.
Exactly.
That would be, wow,
That's what's so exciting.
truly groundbreaking.
Yeah.
So how will Dragonfly go about actually looking for these biosignatures?
So Dragonfly is equipped with this awesome suite of instruments designed to analyze the composition of Titan's surface, atmosphere, and even its subsurface.
Oh, wow.
One key instrument is the mass spectrometer.
Okay.
It will help determine if those methane lakes, which are like vast oceans on Titan, contain any dissolved organic compounds. Now, that would be a huge clue for potential life.
Yeah, that would be amazing. So Dragonfly is flying around, analyzing the surface, sampling the lakes.
Yep.
Sounds pretty ambitious.
It is.
We know it's launching in 2028
Huh.
on a SpaceX Falcon Heavy rocket
Yeah,
from Kennedy Space Center.
that's right.
And with a price tag of over $250 million.
Yeah, a big project.
You know, that really tells you how seriously NASA's taking this.
Yeah.
But who are the people making this happen?
The Dragonfly team is made up of experts from all over the world.
Wow.
It's not just rocket scientists.
Right.
We've got engineers, chemists, planetary scientists, and more.
Wow.
It's a true collaboration,
That's so cool.
bringing together the best and brightest to tackle this extraordinary challenge.
You know, speaking of challenges, there's been some talk that this mission's just too risky.
Mm-hmm.
So how is NASA addressing those concerns?
Well, the Dragonfly team is taking a very cautious approach,
Okay.
rigorously testing every aspect of the mission
Mm-hmm.
to try to ensure its success.
Right.
They've been working on this for years, modeling Titan's environment,
Right.
refining the design of the drone,
Yeah.
and developing really robust flight control systems to handle any unexpected situations.
So they're really trying to think of everything.
Yeah, as much as they can.
Because even with the risks, the potential payoff is just enormous.
It really is.
We're talking about potentially revolutionizing our understanding of life itself.
Totally.
If Dragonfly finds evidence of life on Titan, even microbial life,
Mm-hmm.
it would mean life isn't unique to Earth.
Right.
And that is, wow.
Yeah.
That is huge.
If life can exist in two places in our own solar system,
Yeah.
imagine the possibilities for life elsewhere in the universe.
That's pretty incredible.
Yeah.
Okay, that's a lot to unpack, even for a deep dive.
I know, right?
But before we, get lost in the cosmos,
Yeah.
I want to bring this back to Earth for a moment.
Okay.
We've talked about the atmosphere, the possibility of finding life, but there's more to it than that, right?
Right.
What are some of the other scientific goals of this mission?
One of the other key areas of focus is going to be on Titan's methane cycle.
Oh.
It's analogous to Earth's water cycle, but with methane instead of water.
Interesting.
So understanding how methane is formed, transported, and broken down on Titan
Yeah.
could give us insights into the complex interactions between a planet's atmosphere, surface, and climate.
So it's not just about Titan itself.
Right.
It's about gaining a deeper understanding of planetary processes.
Exactly.
That could be relevant to other worlds as well.
Absolutely. Titan is this incredible natural laboratory for studying planetary science.
Wow.
And the insights we gain from Dragonfly could be applied to our understanding of other planets and moons, even those beyond our solar system.
Wow, you really have to let that sink in for a moment.
It's pretty mind-blowing.
Titan is like a key to unlocking a whole universe of knowledge.
Yeah.
That's amazing. We're just scratching the surface here.
Yeah, we are.
There's so much more to discover about this enigmatic moon.
There is.
Well, luckily, we've got plenty of time to delve deeper into the Dragonfly mission.
Yes, we do.
Stay tuned as we continue our deep dive,
Okay.
exploring the technology,
Sounds good.
the science, and the human spirit behind this incredible endeavor.
Looking forward to it. It's fascinating how this whole mission came about.
Yeah.
It wasn't just this sudden
Yeah.
eureka moment.
Right.
It was a slow burn of fascination with Titan that really spanned decades.
So how did this fascination with Titan begin? It wasn't the drone idea that came first, right?
No.
Okay.
Scientists have been intrigued by Titan
Yeah.
ever since the Voyager missions.
Right.
Sent back those first blurry images
Yeah.
in the early 80s.
Mm.
Back then, it was just this hazy orange sphere.
Yeah.
But it hinted at a world unlike any other.
A blurry orange sphere is enough to get some scientists hooked.
It definitely got their attention.
Okay, but then it was the Cassini mission, the one that really put Titan on the map.
Absolutely.
Yeah.
Cassini, which arrived at Saturn in 2004,
Okay.
spent over a decade studying the Saturnian system.
Wow.
And it gave us this unprecedented look at Titan.
Uh-huh.
We saw those methane lakes and seas for the first time.
Yeah.
We learned about the complex chemistry in the atmosphere, and we even got glimpses of the surface, thanks to Cassini's radar.
Yeah, that's when the idea for Dragonfly started to take shape, right?
That's right.
A way to explore this world that no other mission could.
Precisely.
Yeah.
The Cassini mission was incredibly successful,
Yeah.
but it did have its limitations.
Okay.
It was an orbiter,
Right.
so it could only observe Titan from afar.
Yeah. Yeah.
So scientists realized that to really understand this moon, we needed to get down on the surface.
Okay.
And a traditional rover just wasn't going to cut it.
Right.
Titan's landscape is diverse,
Yeah.
with dunes, mountains, plains, and those vast methane seas.
Right, like a little car stuck in its lane.
Yeah, a rover would be limited in what it could explore.
So someone had the brilliant idea, hey, why not a drone?
Well, the idea of using a rotorcraft to explore another world had been floating around for a while.
Okay.
But Titan, with its dense atmosphere and low gravity,
Yeah.
turned out to be the perfect place to put that idea into practice.
Yeah. Makes sense now that the atmosphere that makes it so hard to see is the same thing that makes it easier to fly.
Exactly.
But you mentioned that Dragonfly would be exploring Titan's methane cycle.
Yes.
Could you explain a little bit more about what that is?
So think of it as Titan's version of Earth's water cycle.
Okay.
But with methane playing the starring role,
Right.
on Earth, water evaporates, forms clouds, falls as rain, flows back into the oceans.
Right.
On Titan, It's methane doing all that,
Okay.
evaporating from lakes, forming clouds, and raining back down.
Wow, so there are actual methane rainstorms on Titan.
Well, it's not exactly like the downpours we get here on Earth.
Okay.
Methane rain on Titan is more like a drizzle.
Mm.
And because it's so cold,
Yeah.
it might even snow methane.
Wow. But the principle is the same, right?
Exactly.
A cycle of evaporation, condensation, and precipitation.
That's right.
And this cycle really plays a huge role in shaping Titan's climate and its surface features. So, by studying Titan's methane cycle, can we learn about how similar cycles might work on other planets and moons?
Exactly. It's all about comparative planetology. Understanding the processes that shape worlds beyond our own.
Right.
And what we learn about Titan's methane cycle could even help us better understand our own planet's water cycle.
Oh, wow.
And the impact it has on our climate.
So we're using another world to better understand our own.
Exactly.
That's pretty incredible. It really highlights why this mission is so important.
It is.
But let's talk about how Dragonfly will actually study this methane cycle.
Okay.
What kind of instruments will it be using?
So Dragonfly is carrying a suite of sophisticated instruments.
Yeah.
And several of them are directly related to studying the methane cycle.
Okay.
It has meteorological sensors to measure temperature, wind speed, and atmospheric pressure.
So like a flying weather station.
Yeah, but a million times cooler.
Yeah, because it's on Titan. But how will Dragonfly tell us about the surface, the lakes, the ground beneath?
That's where Dragonfly's drills and sampling systems come in.
Okay.
It can land near a methane lake or sea, drill into the surface,
Wow.
and collect samples to analyze.
Oh, cool.
These samples will tell us about the composition of the lake bed, the sediments, and even the rocks below.
So I'm picturing Dragonfly hovering over a methane lake.
Yeah.
Lowering its drill and collecting samples. It's like something out of a science fiction movie.
It's pretty amazing.
But speaking of science fiction, let's get back to the possibility of life on Titan.
Okay.
You said it might not look anything like life on Earth.
Right.
What did you mean by that?
So life on Earth is based on water as a solvent.
Okay.
And it relies on DNA and RNA for storing and transmitting genetic information.
Uh-huh.
But on Titan,
Yeah.
with its abundance of methane and other hydrocarbons,
Right.
life could have evolved in a completely different way.
So we're talking about life that doesn't need water,
Potentially.
that might have a completely different biochemistry.
It's possible.
That's mind-blowing. But how would Dragonfly even detect such alien life?
That's a great question, and it's one of the biggest challenges of the mission. We can't just look for the familiar biosignatures,
Right.
the ones we know from Earth.
Of course.
We have to be open to the possibility of life as we don't know it.
So what are some of the things Dragonfly will be looking for to detect this potential alien life?
So one key thing is going to be the presence of complex organic molecules,
Okay.
the kind that are essential for life as we know it,
Yeah.
but maybe in different combinations or forms than we're used to.
Right, right.
So Dragonfly's mass spectrometer will be crucial
Okay.
for analyzing these molecules and looking for patterns that suggest biological processes.
It's like looking for a fingerprint, but a fingerprint of alien life.
Exactly.
That's both exciting and a little bit scary.
It is. It definitely pushes the boundaries of our understanding of life.
Yeah.
But that's what makes this mission so groundbreaking.
Right.
We're not just going to tighten to find familiar things.
Yeah.
We're going there to challenge our assumptions and expand our horizons.
I love that, challenging our assumptions and expanding our horizons.
Yeah.
It's a reminder that exploration is about more than just finding new places. It's about finding new ways of thinking.
Exactly.
And that brings us to another key aspect of the Dragonfly mission,
Yeah.
the element of time.
Yes.
This isn't a quick trip.
It is not.
It'll take 7 years for Dragonfly to reach Titan, arriving sometime in 2035.
That's right.
7 years. That's longer than some college degrees.
It is a long journey.
What will Dragonfly be doing during all that time? Just cruising along, listening to space tunes?
Well, not quite.
Okay.
The journey to Titan is a long one,
Yeah.
but it's not wasted time.
Okay.
The spacecraft will be using that time to calibrate its instruments,
Right.
make observations of the interplanetary environment, and prepare for its arrival at Titan.
So it's not just sitting idle.
No, it's not.
It's gathering data.
That's right.
Yeah, getting ready for the main event. Exactly. Okay, but once it arrives, how long will Dragonfly actually be exploring Titan?
So the primary mission is slated for 2.5 years,
Okay.
but there's a possibility of extending it if Dragonfly remains operational
Right.
and continues to make valuable discoveries.
So there's a chance we could be getting data from Titan for years to come.
That's the hope.
Wow, that's fantastic. But let's say the primary mission is completed.
Okay.
What happens to Dragonfly then?
Well, unfortunately, there's no way to bring Dragonfly back to Earth.
Okay.
It's a one-way trip.
Right.
But even after the mission ends, the data it collects will continue to be analyzed for years, potentially leading to new discoveries and insights.
Okay.
Long after the drone itself has fallen silent.
So it's like a legacy, a gift that keeps on giving even after the mission is over.
Yeah, I like that way of putting it.
But what about the human side of all this? We talked about the team behind the mission.
Yeah.
But what will it be like for us back here on Earth to experience this unfolding millions of miles away?
That's a wonderful question.
I mean, it's not like we can hop on a rocket and visit Titan ourselves.
Not yet, at least.
Right, at least not yet. So how will we be a part of this journey?
Through the images, the data, the stories that Dragonfly sends back to us, we'll be able to see Titan through its eyes.
Yeah.
Experience its alien landscapes.
It's amazing.
And share in the thrill of discovery as it unfolds.
Yeah, I can already picture myself just glued to the screen.
Me too.
Watching as Dragonfly takes its first flight on another world.
It's going to be incredible.
It'll be like a whole new era of space exploration, something that we can all be a part of.
Exactly. And it's not just about the science.
Right?
It's about the human spirit of curiosity, our drive to explore the unknown.
Yeah.
And our desire to understand our place in the cosmos.
It's almost like Dragonfly is a symbol of that spirit.
I think
carrying our hopes and dreams with it as it ventures into the unknown.
That's a beautiful thought.
But speaking of venturing into the unknown,
yeah,
we've covered a lot of ground here.
We have.
But there's one big question we haven't addressed yet.
Okay.
We've talked about all this incredible science Dragonfly will be doing, the search for life, the study of Titan's methane cycle, but what if, and this is a big what if, Dragonfly actually finds evidence of life?
Right.
What would that mean for us here on Earth?
That's the ultimate question, isn't it?
Yeah.
The one that has driven our exploration of space for centuries.
Yeah.
To find out that we're not alone in the universe. That life has arisen in a place so different from our own planet.
It's almost too big to comprehend, you know. We're so used to thinking of life as this Earth-centric thing.
I know.
But if it exists on Titan, it would change everything.
Absolutely.
Our whole perspective on life, the universe, our place in it all.
It would be a paradigm shift.
Yeah.
Of epic proportions. It would mean that the seeds of life could be scattered throughout the cosmos, waiting to take root in environments we might not even imagine yet.
It would open up a whole universe of possibilities.
Literally.
It's both exhilarating and a little terrifying, isn't it?
Yeah, it is.
I mean, what would it mean for humanity to know definitively that we're not alone?
It's hard to say for sure how humanity would react.
Yeah.
But I think it would spark a profound sense of wonder and a renewed appreciation
for
the fragility and interconnectedness of life.
Right.
You know, it would also raise a host of ethical questions.
Oh, of course.
About how we approach exploration and our responsibility to other life forms.
That's a really good point. If there is life on Titan, even microbial life,
right,
we need to approach it with respect and caution.
Absolutely.
We don't want to repeat the mistakes we've made here on Earth.
Agreed.
But let's not get ahead of ourselves. We're still years away from Dragonfly even landing on Titan.
That's true.
A lot can happen between now and then.
Yeah, who knows what the future holds.
And even if Dragonfly doesn't find definitive proof of life, the data it collects will still be invaluable. It's absolutely.
For understanding Titan, its potential for habitability.
Yeah.
And the conditions that might lead to the emergence of life elsewhere.
It's going to be a treasure trove of information.
So no matter what Dragonfly finds, it's going to be a win for science.
Absolutely.
And for our understanding of the universe.
For sure.
You know, it's a reminder that exploration is always worth it.
Yeah.
Even if we don't find what we're looking for, sometimes the journey itself is the greatest discovery.
Well said.
And I think that's a great place to wrap up our deep dive into the Dragonfly mission.
Yeah, I agree.
We've covered a lot of ground, from the unique characteristics of Titan to the innovative technology of the drone itself, the search for life, and even the philosophical implications of finding it.
It's been quite a journey.
Yeah, and I hope you, our listener, have enjoyed joining us.
Me too.
It's missions like Dragonfly that remind us of the power of human curiosity.
Definitely.
Our drive to explore the unknown and our capacity to dream big. And who knows, maybe someday, thanks to the groundwork laid by Dragonfly.
Yeah.
We'll see humans walking on Titan, exploring its methane lakes and marveling at its alien beauty.
Now that's a vision worth holding on to.
It is.
Until then, keep looking up, keep asking questions, and never stop exploring the wonders of the universe.
Well said.
Thanks for joining us on the Deep Dive.